Today we are doing 5.6. We are graphing transformations of functions. Go ahead and write your name on here. And your hour. 5.6 is the second to last section of chapter 5. 5.7 is last. Today we are graphing transformation, so we're going to go from an equation to a graph. 5.7, we're going from a graph to an equation. So if you can do today, Mondays is literally the exact opposite. So this is really the last thing we're learning, and then on Monday you just got to do the opposite of this, and then you will have learned everything for the entire chapter. So today we're graphing transformations. Transformations of functions are when we look at a function or an equation, and instead of having to plug numbers in to make a graph, we are able to decide where on our coordinate plane, where on our graph that graph should go. We have three parent functions. What a parent function is it's like the starting original function before we move anything. This is the linear function f of x equals x. We are not going to be transforming this today. These are the two functions that we need to know. This is f of x equals x squared, which is a quadratic function. This is a quadratic function starting at the point 0, 0. So see those 5 bold dots on there? That's what you need to know about a quadratic. You need to know that there's a dot right here in the middle. And then from there, you go up 1, out 1. And then from there, you go up 3, out 1. So those 5 dots. So start in the middle. And then to make a quadratic, you go up 1, out 1, up 3, out 1. The reason why a quadratic looks like that is if we were to plug in numbers, if we were to plug in 0, we would do 0 squared and get 0. We plug in 1, we get 1 squared is 1. We plug in 2, what's 2 squared? 4. That's why this point's all the way up here at 4. Then on the negative side, what is negative 1 squared? 1. Why is it positive? Jinx. Okay, so negative times negative is positive, so it's positive 1. And then negative 2 times negative 2 is positive 4. So that's why the graph looks like this. Any questions about this original parent function? We're going to take that shape and we're going to move it around on our graph. What's up, Shyla? Okay. Absolute value functions. Absolute value is the distance from 0. So, how far is the number 0 from 0? 0. How far is the number 1 from 0? How far is negative 1 from 0? How far is negative 1 from 0? 1. So, 0, 0, and then see how these are the same distance? They're both 1 away from 0. 2 and negative 2 are both 2 or 2 away from 0. Distance is always positive. So that's why your absolute value starts at 0, 0, and then it goes up in both directions. So this is our V-shaped graph. This is our U-shaped graph. We need to know that quadratics are U-shaped. We start at 0, 0, and then go up 1, out 1, up 3, out 1. We need to know that this, you just go up 1, out 1, up 1, out 1 on both sides, okay? So those are the two graphs we're going to be graphing today. Okay, so our parent functions, so these functions, they can be transformed or moved. So we're going to move them around on our graph. Today, we are going to be transforming our quadratic and our absolute value functions. So, quadratic and absolute value is what we're moving today. The reason why we're not transforming our linear functions is a transformed linear function is just in slope-intercept form, and we already did that for an entire unit. We're not doing it again. So we already learned to graph linear functions in Unit 3, so we don't need to do it again. Okay, right now, any questions? Okay, I'm gonna go ahead and flip this over. We're gonna come back and fill out this table, but I want to show you guys what the problems look like on the back. Okay, I'll flip it back over in a sec. So this is what the problems look like. So we are going to figure out how to graph f of x equals x squared plus 3, absolute value of x minus 2, x plus 5 squared plus 3. So we will be able to take this function and graph it just using a couple rules of moving our graph up, down, left, and right. We won't have to plug anything into a calculator. All we're going to do is give ourselves directions. So this is what we're going to be graphing. So I'm going to go ahead and flip this over. Let's fill out this table down here, and I'm going to tell you those rules. We are going to be doing adding and subtracting, and we are going to add inside of a function and outside of a function. I will show you the difference between inside of a function and outside of a function. Adding and subtracting, inside and outside, do 4 different things: up, down, left, and right. If you do something inside of the function, that's going to move you left and right. If you do something outside of the function, that's going to move you up and down. Okay, if you're currently on a note, not on a nose or in a phone, if your phone is out or your nose is out, please pay attention right now. This is something that's completely new for you guys, I think. All right, if you add inside of a function, your graph is going to move left. So what goes on this line here is the word left. If you subtract inside of a function, your graph is going to move right. So adding inside moves us left. Subtracting inside moves us right. It's the opposite of the way for the inside ones than you want it to be. And the reason why is because when you add inside of a function, you're impacting the input, not the output. So it just changes the function at a different point. Ms. Vandervoort and I were just talking about this. Just believe us. Just go with it. Don't stress out. We are going to give you examples of what it looks like to add or subtract inside. So a quadratic function with adding inside is going to look like this. F of x equals, and then open a set of parentheses, and then let's put x plus 5 in parentheses and put the squared outside. Five is just a random number I'm picking to use as our example because it's just a nice number. For an absolute value function, it would look like this. F of x equals the absolute value of x plus 5, and then close your absolute value signs. To subtract inside is going to be the exact same thing, but minus signs instead. So f of x equals x minus 5 squared, or f of x equals the absolute value of x minus 5. Okay, so these two functions, this one you would take an x squared function, so you would take the u-shaped graph, you would just scoot it left 5. This one you would take the v-shaped graph, scoot it left 5. This would scoot right 5 and right 5. So adding or subtracting inside, adding moves us left, subtracting moves us right. And that's what it looks like to be inside of a function. You're inside what's being squared, and you're inside the absolute value signs. Questions about him? Those. That. Okay. Outside impacts it the way you want it to be. Adding outside moves you up. Subtracting outside moves you down, the way you want it to be. So adding outside is going to look like this. F of x equals x squared, and then after the squared, we have the plus 5. And again, I just picked 5 randomly. It's the example I'm using. Adding outside of an absolute value will look like this. You'll have f of x equals the absolute value of x, and then the absolute value sides just go around the x, and then your plus 5 would go after. Okay, subtracting outside is going to be the same thing, but subtracting instead. So f of x equals x squared minus 5, or f of x equals the absolute value of x minus 5. So get that whole table filled out. And then we are going to use this table. This table is everything you need to know, basically, for 5.6 and 5.7. 5.7, we use the exact same table. Okay. Anybody need more time to fill out the table? Anybody still writing? All right. Here's how you use the table. You look at the function, and you say, am I adding or subtracting? Am I inside or outside? If you are adding outside, you say add outside. Okay, I move up. Subtract outside. Okay, I move down. Oh, I'm adding inside. I go to the add column, the inside row. Subtract column, inside. So you read the table in 2 directions and figure out where you are. Add, subtract, inside, outside. Go ahead and flip this over. Let's look at the back. And do you guys see the difference between inside, outside, inside, outside? You see how that's inside and that's outside, inside, outside? That's important. Okay, flip this over then. All right, so here's what you have to do. Identify each parent function. Then identify the transformations. Sometimes there's 1, sometimes there's 2. And graph the transform function. That's what you're doing. So then fill out the blanks and draw your graph. I'm going to zoom into this first one here, if I can figure out where my zoom button is. Okay, f of x equals x squared plus 3. Here is how you identify the parent function. You say, is there a squared or are there absolute value signs? This one is x squared because there's a squared. So you just ignore the numbers. Whatever is left without the numbers is your parent function. So you can just write down x squared here. Then you have to follow the directions of the numbers. So right here, am I adding or subtracting? Adding, am I inside or outside? Outside. So if I was inside, it would be like, that's inside, okay? So that's inside, this is outside. So I'm adding outside. So if you need to write down a little note to yourself that says, add out, so you know where to go read your table, you can. According to the table, what does adding outside do to my graph? Up, down, left, right. Up. So you go find on the table, add outside moves me, oh, sorry, you can't see that. Add outside moves me up. Okay, so then my transformation line, I need to write either up 3, or I like to write U3. So up 3. You can write up. But once we get to the other ones where you have to do 2 transformations, they're usually not spaced to write the whole word. That's why I just write U, D, L, and R. Okay, so up 3. So then, here's what you do. Put your pen or pencil at 0, 0. Move it up 3 and put a dot. That dot is where you start your graph. We have to make sure we draw the correct graph. This is x squared, so we draw the U-shaped graph starting at that dot. So from that dot, we go up 1, out 1 on each side. So put those next 2 dots, go up 1, out 1 on each side. And then for the U-shaped graph from there, you have to go up 3, out 1. So up another 1, 2, 3, out 1. Up another 1, 2, 3, out 1. And then once you've got all your dots, you can make a nice little U. All right, any questions about that first one? You're basically giving yourself directions and then following directions. The function gives you directions. You just have to translate them into what they mean. Next one. F of x equals absolute value of x minus 2. Okay. Parent function is absolute value of x because literally just ignore the numbers. Whatever's left without the numbers is your parent function. Then, am I adding or subtracting? Subtracting inside or outside? Inside. Any questions on how I know I'm subtracting inside? Okay, subtracting inside moves me right. So I'm going to move right 2. The number that you are adding or subtracting, that's how far you go. So where it is and whether it's adding or subtracting tells you the direction to go, and the number tells you how far to go. So I'm going to go right 2. Any questions about that guy? Cool. So then put your pen or pencil at 0, 0. Don't actually mark anything. Move it right 2. Just follow your own directions. Then we need to make our V-shaped graph. V-shaped graph is easier to make because you just go up 1, out 1 twice. You could go further than that, but I only go twice because that's plenty. That's a little V. A little V-shaped graph. Because it's absolute value. So whether it's x squared or absolute value, there's also like a gajillion more functions we can transform, but these are the ones that you're supposed to learn in Algebra 1. Okay. Any questions about either of those ones? Okay. We're going to move on now to the rest of the examples. The rest of the examples have 2 transformations. Because instead of just going left or right or up or down, you can go left or right and up or down. You're never going to go both left and right, though, because those would just cancel each other out. You're never going to go both up and down. So there will always be one thing inside that'll move you left and right, one thing outside that'll move you up and down. Okay, parent function on this next one. You ignore everything except for the plus 5 and or you ignore the plus 5 and plus 3. Whatever you have left is your parent function, so this parent function is x squared. Any questions about that? Ignore the plus 5 and the plus 3, and you're either going to have x squared left or absolute value of x left. So ignore the adding and subtracting numbers, and whatever you have left is your parent function. Okay. Then we have to do some big brain stuff and make 2 decisions. We are adding 5 inside. What does adding inside do for me? Left. So adding in, I'll write here, add in, moves me left 5. Then my plus 3 out here is adding out. What does adding out do? Up. So I go left 5, up 3. So that's what the 2 lines are. You always going to go left or right first because that's what's going to happen inside. and then go up or down second. Any questions about that? Okay. Put your pen or pencil at 0, 0. Move it left 5 and up 3 and put your dot there. Don't put a dot left 5 because that'll confuse you. Put a dot, go left 5 and go up 3. Okay, then from there, it's the U-shaped graph. So we're going to go up 1, out 1 on each side. And then up 3, out 1, which takes us all the way to the top. And then make it U-shaped. You do have to connect your little dots so we know it's a graph. Okay. Any questions about that? Cool. We're going to do one more together, and then I'm going to have you guys try a couple, the last two on your own, and we're going to check them. So let's do one more together. This fourth one here. Absolute value of x plus 4 minus 3. I just said it. What's my parent function? Your only two choices are x squared or absolute value. Absolute value. So you ignore the plus 4 and the minus 3. Whatever you have left is your parent function. All right. Then our transformations, we add in, subtract out this time. So add in and subtract out. So adding inside, we did that on the last one. We know that adding inside moves me left. So I'm going to go left 4. And then subtracting outside moves me down. So I go down 3. Left 4, down 3. The number you're adding or subtracting tells you how far to go. So put your pencil at 0, 0. Move left 4. Move down 3. Put a dot. That's the middle of your graph. You go up 1, out 1 on each side, and make a V. That V was not great. There you go. Okay. Questions right now. Okay, I'm going to pause the recording. Hello again, recording. It's us. All right, last two. Parent function on this one. F of x equals, what's my parent function? X squared. All right, minus 3 inside. Subtracting inside moves me right. So I go right 3. Plus 1 outside. Adding outside moves me up. So right 3, up 1. So I go right 3, up 1, put a dot. Then I have to make the x squared graph, which is U-shaped. Make the U-shaped graph. Any questions about that? Check yours and make sure that you either done it or that it is, if you already did it, that it's correct. Okay, last one. If you ignore the minus 4 and the minus 2, all that's left is the absolute value of x. Transformations. Minus 4 inside. Where does minus inside move me? Subtracting inside. Right, so right 4. And then minus 2 outside moves me down 2. So right 4, down 2, put a little dot, make a V-shaped graph, and connect the dots. Okay. Questions right now for the good of the cause. Okay, I'm going to stop the notes then. Bye, video. It's been nice hanging out.